Hey y'all, Coach Hicks here. Just want to do a quick video recapping some of the things we learned last week and setting y'all up for this week. Sorry if the volume is a little crazy. I'm trying to do this on an iPad, so it's a little different than some of my previous videos. Anyway, this is a Punnett square practice one. I need to stress that again, practice. This is not worth any points, but I do recommend going through here and working out some of these Punnett squares. It should be posted right below this video, so you should be able to find it pretty easily in Schoology. All right, so our plans this week, we're going to go over this practice sheet over the next really 2 days together, do a few assignments here and there. So I'm just going to go through a few of these problems on my own right now. I want you to try to follow up and do some of these for, again, practice, okay? So looking at Punnett squares, a few things to kind of remember. Notice that this worksheet tells us these are monohybrid crosses, so we're only dealing with one trait. We're going to draw the Punnett square. And then it talks about listing the ratio and describing the offspring. I really want you to describe the offspring. That's what I'm looking for more. I don't care so much if you do it in a format of genotype and phenotype, because that's not really what's going to help. Really just knowing what percentages, especially things are what's going to help. Let's look at this example together. Notice it says a green pea plant, and it tells us this big G. What does that mean? That means homozygous alleles that are dominant, because a capital letter, right, is crossed with another green pea plant. In this case, a heterozygous. Okay, remember those are terms that we need to know. Homo is when they're exactly the same, whether they're big letter, or little letter. That's hard to say. Or hetero is when the alleles are different. Okay, one of them dominant and one of them's recessive. Remember, dominant is signified by capital letters. Okay, so check out what we do. We take one parent and we put one of the alleles over the top of one column, okay? We put another one of the alleles right there over the top of this column. We're going to take this parent here, the heterozygous, and here's one allele, and here's one allele on the side, okay? We get what's in these boxes by bringing down and bringing over, okay? So big G and big G both come down and over, and that's why we get that, possible allele combo. Same principle in this one, bring it down, bring it over, okay? This one, we bring it down, we bring it over, and that's why we got one big G and then one little g right there, okay? So, and then the same principle here and here. Hopefully you're getting this by this point. That's why we took Thursday to really talk about it. So whatever it gives us, we set it up in the Punnett square, and then we're really looking for, this information in the Punnett square here. Out to the side here, it just simply tells us what we can observe from this. We can see that there's two big G combos, homozygous dominant. We can see that there's two, heterozygous combos. What we really want to look at in the big perspective, as we'll see in some quizzes and things like posted down here below, is we're looking for what's the probability that something, looks a certain way, that the offspring might be green or yellow or whatever. And we know looking at these that there's 100% chance that they're going to be green, right? Because that dominant allele is in every one of these. So let's just look at number one together. This will give us a better perspective. First, let's set up the Punnett square, right? A green pea plant, heterozygous. So I'm going to go ahead and put it over here, heterozygous. Okay, put one letter over each column. Is crossed with a yellow pea plant, little g, homozygous, recessive. So I'm going to put those out to the side here, okay? In these, the first 5 here, it all gives us the allele combo. Later on we need to know. So we need to know this is heterozygous, this is homozygous recessive. But for now, let's just fill it in, bring it down, bring it over, bring it down, and bring this one all the way over. So that's a GG, little g. Bring down, bring over, bring down, bring over. So let's just look and observe what we can tell, okay? First off, I noticed that 50% of them, sorry, my pen's getting a little wonky, is heterozygous. Okay, 50% chance that those offspring would be homozygous recessive, okay? And now I want to think about the phenotype. Remember, this is just me writing. This is all practice, right? It's all practice, practice. All right? So I would look at this. The offspring have a 50% chance of being green, okay? And that is simply because 50% of them have that dominant allele as one of their pairs, okay? Then I would also notice that 50% of them are most likely to be yellow because of this homozygous recessive combo. This homozygous recessive combo right here, okay? Showing that they don't have any of those dominant alleles and so therefore they have to be yellow. So this is really what we're trying to get to. So if we cross these, what's the probability that they're going to be yellow? What's the probability they're going to be green? 50%, right? 50%. Okay, let's do the next one together, and then we're going to move on to some other stuff. A tall plant, and it gives us the homozygous dominant, is crossed with another tall plant, heterozygous. So let's fill in, right here, big T, okay, over each column. Then we're going to fill this one in, big T, little t. And now let's bring down, bring across, right? Bring down, bring across. Once you do it a few times, you'll be able to figure this out. So let's just glance at what we see here. We see that 50%, again, that's some horrible writing, sorry, y'all. 50% is going to be homodominant, 50% going to be, heterozygous. We can look at that and go 100% of the time, the offspring are going to be tall, okay? And that's because they have a dominant allele represented. All right, let's go down. I want you to practice, 3, 4, 5 here, and they should be easy. Just set it up. Use these to set up, the parents. And then, of course, cross out the Punnett square, and then just kind of write down some information, anything you can glean off of it about what you see probability-wise. Oh, and no number 6. I didn't realize there was 6 of them. All right, let's glance at these. I want you to do these for practice as well. So, but these are a little bit harder. You got to think about in the beginning. So read carefully. A homozygous dominant brown mouse is crossed with a heterozygous brown mouse. And then it even tells us tan is the recessive color. So I might would come over to the side and just say, what are my options? They're either going to be brown or they're going to be tan. All right, and tan is the recessive. So I'm going to use B's. So this would be a little b, okay, and brown signified by a big B. All right. So think about the allele combos that we could have. All right, there's always 3. You got your homozygous dominant, your heterozygous, and then your homozygous recessive, right? These are the only 3 options that we got. So let's look at parent number 1 right here, okay? A homozygous dominant. Whoop, right there it tells me. So big B, big B. I'm going to go ahead and fill it in my Punnett square, okay? And then a heterozygous brown mouse. Whoop, right there. I'm going to go ahead and fill it in my Punnett square, okay? And now I'm just going to take time. Oh, something's going on with this. Let's just cut that crap. All right, big B, and then I'll bring it down, bring it over, bring it down, bring it over, bring it down, bring it over. So check out what we got. Just glancing at it, what's the possible offspring? We got homozygous dominant or heterozygous, and it's 50% on each, right? Now I can look at this and go, brown's the dominant color, and both of these options have brown. That tells me 100% of the offspring are going to be brown, right? Because that dominant allele shows up in both of them. That also tells me 0% of the offspring could be tan, all right? And these are the real info that I'm looking for, right? That's what we really want to know. What we're looking for, the genotype is nice. The genotype tells us a good bit, but we really want to know, what are they going to look like, right? What are they going to look like? Let's just do the next number 2 together. I think I got time. 2 heterozygous white, and it tells us brown fur is recessive, rabbits are crossed. So let's just use, W's look hard, so I'm just going to use, you can use any letter you want to, remember. Let's just write it over here, white, we're going to signify with H, okay, big H, because that little H right there maybe. And the W, big W, little W just looks the same, right? So, and then I'm going to say, you can use whatever letter you want, just make sure you use the same one all throughout the Punnett square. Brown going to be little h, all right? So that's just me giving me a mental note. All right, 2 heterozygous white. So heterozygous, remember, when their allele pairs are different. So these are the 2 parents. Let me write them in here. Okay, bring down, bring over. Get out of here. I don't know why it's doing that. Sorry, y'all. Bring down, bring over. Bring down, bring over. Bring down, bring over. Bring down, bring over. All right, so now we got a few things going for us here. Look at the allele, let's mark that out. Combos, we got homodominant, we got heterozygous, and then we also got a homorecessive, all right? So think about the percentages here. So I only see 1 out of 4 of this, so that's 25%, okay? I see 1, 2 heterozygous, that's 50% chance of being that. And then I see 1 out of 4. 25%. Remember, these are easy percentages. These are percentages that you can do in your head, hopefully. All right, so what percentage will be white? I see 1, 2, and 3 of them have dominant. So white, 75% chance that this mixture of these rabbits, 75% chance that they would have white fur. Of course, with that, 25%, because that's all that left, would have brown. Sorry, my writing is so bad, y'all. All right, so my time's probably running up on this recording. I want you to try to do 3, 4, and 5 on these. It might help you. It really might, to write out beforehand, like perspective, heterozygous white and homozygous black, to think about, what are they crossed up as? Some of them you got to kind of use your head. If it's a homozygous black rabbit, it don't really tell you which one's dominant or recessive. Doesn't really matter on that one because, look, you kind of got to use your head. If a heterozygous white rabbit, we know hetero has got a big letter and a little letter. Let's just use, whatever, B's here. Okay. Now let's just use a W. Okay, so big, it sucks. Let's not use W. Let's use, let's just go to T. T's always my go-to because they look different. If it's heterozygous, we know it's going to be big and little. And if it's white, we can see that the dominant one's going to be seen, right? So that tells us big T is white and little t is black, okay? Now look at what it tells you about these two crosses. That's the first parent, heterozygous white, and then a homozygous black. The only way that it can be black is if both of them are little t, okay? So you just kind of got to use your head. And it kind of gets a little fun, at least it does to me, when you have to start really using your head on these crosses and what we see going into them. So I want you to try these for, again, practice, okay? And then there'll be a little quiz down there below it. There'll also be some scratch paper and things that you may need. All right, don't be scared to email me this week. You ain't got to do it all today. Take your time, kind of go through it. If you got pen and paper there, you may want to draw the Punnett squares on pen and paper instead of using the digital stuff, all right? I can't stress enough, this is for practice. The quiz stuff is for a grade, and I promise we'll kind of go over all this next week going into it, so don't feel scared, don't feel alarmed.